kids, Miss Kulkarni here. In this video, let's talk about IHD. So what does IHD stand for? This is the index of hydrogen deficiency. Let's find out more about what it means and how we find out this value. So do you want to know the definition of IHD? It is simply called as a measure of unsaturation for a compound. And as you know, saturated compounds are usually, we call those compounds with single bonds. And if you have a double, triple bond, we have used those as unsaturated compounds. But how can we find out the degree of unsaturation? So what information we can find out? This can give us the count of how many molecules of hydrogen we need to add in order for our structure to make a saturated compound. So for example, if you have an unsaturated compound, how can you make it saturated? How many more hydrogen atoms we can add? It's that simple. And now there are two different methods of finding out this. One of the method is using the structure. The structure, we are going to look for rings, how many rings it has, and also how many multiple bonds it has. So using these two values, we can pretty much decide for most of the figures what IHD value is. So IHD values is multiple bonds plus rings, and we can also say in simple way it's P plus R. So double bond, we can add 1 degree of saturation. A triple bond has 2 degrees of saturation. A cyclic ring, the ring itself will add 1 degree of saturation. And if it is aromatic ring, in which suppose if we are adding extra double bonds to that, like the benzene, we have 1 for the ring, and we also count the double bonds, and those are 3 double bonds here. So we add that and we count that as 4 degrees of unsaturation. Now here is the method 2, and this works well if you have large molecules. Instead of drawing the structure and counting the rings and double bonds, we can simply use the molecular formula. And in molecular formula, we look for all these values. So if your formula has carbon, hydrogen, nitrogen, oxygen, and a halogen atom, IHD equals 0.5 times it's 2C, number of carbon atoms, plus 2 minus H, that's number of hydrogen atoms, minus X, which is the number of halogen atoms, and plus N, which is the number of nitrogen atoms. So just remember, determining IHD can be helpful for us, and we can actually see what type of structural units may be possible in that. And sometimes the molecular formula helps us. And sometimes it's an easy, quick way to check on structure and see if it fits into the molecular formula instead of simply counting the hydrogen atoms when we can actually make some mistake. So both the methods have their own value. Now let's actually work on some examples. So in this first example, instead of using the big long formula, I'm rather going to use the number of rings and number of multiple bonds. So obviously, I don't see any rings in this formula, but I clearly see there are 2 double bonds. So I can list it. How many double bonds we got? We got 2 double bonds. Each double bond counts for 1 degree of unsaturation. So we got degree of unsaturation as 2, and that's all we got here. So IHD will be equal to 2. Let's look at the second example. Again, our focus is going to be on how many bonds we got. So we only had double bonds, no triple bond in this example, and we got 2 double bond. Each one counts for 1 degree of unsaturation. So total comes 2, and IHD will be equal to 2 for this. Look at the third one. We got a triple bond, just 1, but triple bond counts for 2 degrees of unsaturation. So this is again going to be 2 as IHD. Now moving on, you can see there are 2 double bonds, and each double bond qualifies for 1 degree of unsaturation. Since we got 2 double bonds, we got IHD equals 2. Now, did you realize if you had double bonds in a compound, It doesn't matter where they are present or how big or small is the molecule. If the number of double bonds was 2 in all the molecules which we talked about, IHD will be still equal to 2. Let's look at the next example. It's interesting. You can clearly see there is one ring here and this second ring here. And since each ring qualifies for 1 degree of unsaturation and we got 2 rings, we got 2 degrees of unsaturation from that. And then did you notice there is one double bond present there? So that one qualifies for extra 1 degree of unsaturation. We add those 2 things and we end up getting 3 as our IHD. Let's look at the third example. Okay, now we can do it in steps or we can directly do it. This ring is an aromatic ring, and as you remember, the aromatic ring was giving us the degree of unsaturation as 4, and then we also got one more double bond there, so that double bond equals to 1 degree of unsaturation. So total when we add, that comes out to be 5. Alright, now let's switch gears. Let's find out IHD using the big formula. So that formula is 0.5 times, we have 2 times carbon atom plus 2 minus H, which is hydrogen atoms, minus X, which is the halogen atoms, and plus N, which is the nitrogen atoms. So the first example is C6H10. Obviously, we don't have here any halogen or nitrogen atom. So let's plug in the values here. C is equal to 6 and then H is equal to 10. So our formula is 0.5 times 2C will be 6 times 2, which is 12, plus 2, and then minus hydrogen will be 10. And unfortunately, we don't have any X or N. We can write minus 0 and plus 0 if you want to, but it doesn't matter. And when we simplify this, what we get is 0.5 times 4, so that equals to 2. It's that simple. Let's work on the next example. Again, carbon atoms is 6 and hydrogen atoms is 6. So our formula for IHD is 0.5 times 2C will be 6 times 2, which is 12, plus 2, minus the hydrogen atom, which is 6. And of course, we don't have any halogen atoms or nitrogen atoms, so I'm going to stop it over here. And when we solve that, we get 0.5 times 8, which gives you the answer 4. Look at the next one. This compound here got one oxygen atom. Let's see what difference it makes. So number of carbon atoms is going to be 4, hydrogen atoms is going to be 8, and oxygen atoms is going to be 1. In our formula, it's 0.5 times 2 times carbon will be 4 times 2, 8, plus 2 minus hydrogen atoms, which is 8, and then it's going to be minus X, which is halogen atoms, which we don't have, and plus nitrogen, we don't have that. So do we really care for oxygen atoms? No, absolutely not. So we're going to just leave it over here, and that becomes 0.5 times 2, which is equal to 1. Don't you think it's getting easier? All right, over here, we got a formula C4H9, and there is a nitrogen atom now. So carbon is 4, hydrogen is going to be 9, and nitrogen is going to be 1. So in my formula, it's 0.5. 2 times C will be 4 times 2, 8, plus 2, minus number of hydrogen atoms will be 9. And then I need to worry about the halogen atoms X, which I don't have. So that's minus 0. And I do have one nitrogen atom, so I'm going to add that to this, so it's plus 1. And when we simplify it, we get 0.5 times 2 equals 1. All right, here are some big molecules. That's the example of cocaine, C17H21NO4. If you draw the structure and count the rings and double triple bonds, it will be a long time for us to figure out. But with our formula, it's going to be easier. So again, number of carbon atoms is going to be 17. The hydrogen atoms is going to be 21. Nitrogen is going to be 1. And do we really care for oxygen? No. So I won't even bother to write down that. So my IHD will be 0.5, and then it's going to be 2 times 17 plus 2. Then it is minus the number of H atom, which is minus 21. I don't have any halogen atoms, so I'm going to put minus 0, and plus I'm going to put 1 nitrogen. And when we simplify, what do we get? 0.5 times 16, which equals to 8. Let's do one final example. Cholesterol, C27H46 and O1. So let's list down that. Carbon is 27, H is going to be 46, and I don't really care about oxygen because that is not in the formula. So let's see what it comes out to be. It's 0.5. Then we end up getting 2 times carbon atom, which is 27 times 2 plus 2, minus the number of hydrogen atoms, which is 46. And that's it, because we don't have any halogens or any nitrogens. So that comes out to be 0.5 times 10 when you work it out. And the final answer is, of course, 5. So what do you think? It is pretty easy to find out IHD, the index of hydrogen deficiency, by either one of the methods. If the formula looks too big, like we saw in cocaine and cholesterol, make sure you use the formula. But if the structure is given to you and it's very easy to count the number of rings and number of double triple bonds, then go by just counting those numbers. All right, I hope you guys enjoyed the video. I'll see you again in next video. Until then, bye-bye.